Hello Legacy students, Marsh here. So today we're going to basically spend the second day on solving log equations and also the second day on log properties. Basically, you're going to need your notes, calculator, and then a pen or a pencil today. So, stuff that we already have done. We've looked at logs on both sides. We've looked at a log on one side, but we have not taken a look at what happens if I have multiple logs on a single side and I can't move it to the other side. Let's take a look, though. Let's do a little bit of review. What do we know? So reviewing, log on both sides. Remember, guys, log on both sides, all you needed to do was set the insides of the log equal to one another, right? Because we said if it's log base 5 of whatever equals log base 5 of whatever, the two whatevers have to be equal to one another. We're thinking equality. Logs on a single side, so log on one side, we just went immediately to exponentials. So that was 2 to the 5th equals x minus 6. And I would add the 6 over, you'd get 38 in there. And also remember, every time we solved these log equations, we always had to check to make sure that we got a positive number inside of the log, because there was a domain issue in a log equation. You can't get negatives nor 0 inside of a log. There is a domain issue there. Ones we have not solved, this in particular. So log base 4 of x plus log base 4 of x plus 12 equals 3. Notice, guys, we have not solved anything that has multiple logs. If I subtract it to the other side, you still have that 3 over here. So that's different than logs on both sides. Here's why those properties that we just learned today were so important. We need the ability to condense this. So right now, this is an expanded form. So I'm going to condense this into a single log. So since there's plus in the middle of two logs, I'm going to change the insides to multiplication. So it's going to be log base 4 of x times x plus 12 equals 3, aka log base 4 of x squared plus 12x, right? Just distribute that x in for myself, equals 3. Now, I am down to a single log on one side. I can now go to exponential form. So I got 4 cubed equals x squared plus 12x. Well, 4 cubed, that's 64. If I move that to the other side, so I get x squared plus 12x minus 64. So I need to think of two numbers that multiply together that give me 64, but add together to give me 12. Four times 16 is 64, and that adds together to give me 12. So it looks like, since I'm looking for a negative 64, it looks like it's going to be a positive 16 and a negative 4. So if I factor that, that'll be x plus 16, x minus 4. Notice, guys, since it's a 1 in front of the x squared, I can immediately jump to that fact. So I get my two answers of x equals negative 16 and x equals 4. Now, definitely, guys, don't forget to check the solutions. Just like when we were solving with regulars without having to do the expanding and condensing, the same things can happen. So one thing I notice immediately, if I plug that negative 16 in right here, I get a negative inside that log. Negative 16 is not an appropriate answer, and it is an extraneous solution. Now if I plug 4 in here, that's fine. Plug in 4 here, that's fine. Actually, you're going to get the answer of 1 plus 2 equals 3, because if this would be log base 4 of 16, which in fact is 2. Let's try one more problem. So I got log base 2 of 5 plus 2x minus log base 2 of 4 minus x equals 3. So first thing I know I need to do is I need to condense this. Since it is subtraction, that means the inside's actually going to be division, right? So I'm actually going to divide the two insides. So log base 2 of 5 plus 2x divided by 4 minus x, and that's equal to 3. Notice all I did, guys, was divide the insides because there was a subtraction in the middle. So let's convert to exponential form. So I get 2 cubed equals 5 plus 2x over 4 minus x, aka this is technically 8 over here, right? 8 equals 5 plus 2x over 4 minus x. How am I going to solve that? Well, if I make this 8 over 1, it's just going back to solving rational equations, right? We did that a long time ago. When we had a fraction equal to a fraction, it's just cross multiplication. So let's multiply 8 by that stuff, so that's 32 minus 8x. 1 by that stuff. And now it looks like just a really simple solving problem. So let's add 8x. Let's subtract 5. So I'll get 27 equals 10x, or x equals 27 over 10. It looks like will be my answer, or 2.7 if you want the decimal equivalent. Double check, make sure it plugs in. So if I plug it in here, 2 times 2.7, that's going to be not a negative. That's going to be okay. 4 minus 2.7, that's definitely all right as well. So that should definitely work. No problems there. And that's the end of this video. So we will do some practice on solving with log properties tomorrow, but until then, I'll see you later, Sabers.